Bonjour, welcome to Wahsa Citizens Education Center's radio Zoom classes. This is SVN3E, grade 11 workplace science, and I'm the teacher, Bronwyn Slade. This class is pre-recorded, so unfortunately you can't join me live, but we will be back live in our next lesson. Our classes are Monday through Thursday from 10 a.m. to 11, and we are now in our second week of our 9-week course. Though it is early, it's still important to recognize what information you do need to submit for marking once you get to that point. So the key questions are the marked questions. They are listed at the end of each of your IL lessons, so please do all of them. Some are check your understanding, sometimes there's an activity, and then also the review questions. Show all of your work, your steps, and your thinking. Make sure you are actually answering the question that is being asked. Give me full sentences. Don't just give me one-word answers. Give me your full thoughts, please. You can do this by hand or electronically. You're welcome to write in your workbook. It is yours to keep, but the spaces are pretty small. So I would encourage you to, if you want to write it out by hand, to answer separately or to type up your work. If you're going to do it electronically, Word and Google Doc files are the ones that are easiest for me to open. But if that is something that is hard for you to do, if you don't have access to those, or you're not sure how to do it, everyone does have access to Google Doc files through their NNEC email account. But you can do a different file type if that's better for you. Just check with me to make sure that I can actually open your files. How to submit your work for marking? The first method is to send your work electronically. So you can scan your completed work in if you've done it by hand, either using an Apple device, the Notes app, which comes along free, has a scan function, or if you have an Android device, the Google Drive app also comes with that device and has a scan function that are both fairly straightforward. Then you can send it to me through email once you have it electronically to studentwork@nnec.on.ca and CC it to bronwyn.slate@nnec.on.ca, or you can send it to me through Facebook Messenger to bslateWahsa. The second method is to drop your work off into Lookout. We have an outdoor mailbox at our 74 Front Street location. We are the bright red building next to the post office, and we have a small white mailbox next to our side entrance. We are not yet open to the public, but hopefully soon. However, this time just put your work into the mailbox and I'll get it back to you as soon as I can. The third method is to hand your work into your DEC. Then your DEC can send your work in through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. All students are welcome to send their work in through fax as well. If they have access to a fax machine, that is fine. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name bslateWahsa. So you can friend me on Facebook or subscribe to my YouTube channel, and then you'll get notifications when I upload new lessons. All of our radio Zoom classes are recorded and posted onto YouTube in a playlist called SVN3E, and they're shared on Facebook. So it's a really easy way, connecting with me through social media, to find our previous classes, and as well as the supplementary videos that I show in class. Science is really visual. I try to put as many visuals, diagrams, pictures, videos in as possible to make it engaging and also really help us understand to the best of our ability. So I strongly encourage you to access the videos as opposed to just listening to the audio on the radio. If you don't have reliable internet and you can't join us live through Zoom, that's completely understandable. But if you let me know, then I can send you a copy of the recordings, and this way you still have access to all of the material. If you have any questions or concerns, please contact me. My email address is bronwyn.slate, which is spelled BRONWYN.SLATE @nnec.on.ca. My Facebook is bslateWahsa. call me at the office at 807-737-1488, extension 2209, or toll free at 1-800-667-3703. My office hours are Monday through Friday, 8 a.m. to 2 p.m., though I teach from 9 to 11 and am not available at that time. If you'd like to connect with me outside of those times, please let me know and we can try to arrange something that works for both of us. I think it's important to position myself in the context of this course every day, as that shapes how I teach. So I have white settler ancestry, I have white privilege, and this means that the way that I've experienced education is very different than many other folks. It's been easier for me because of my white privilege than for people who are not white. I recognize this and I'm working to disrupt this cycle. I live in Northwestern Ontario on the traditional territories of the Anishinaabe people, and I'm working to learn what I can from the community around me. It is a process. It's not something that is easy. Understandably, I'm not welcome in all situations, which makes sense. So it is a slow process that I continue to be working on and value. As an educator, I have lots to learn and unlearn. This is also a lifelong journey of how to unlearn systems of oppression and patterns of education. It's fairly deeply rooted. And so I am working to unlearn those patterns as well as learning new things and new world perspectives. Our textbook is also Eurocentric, is also based on white experiences. And this is definitely problematic. I'm working to find a new resource, but this is what we have at the time. I've noticed that it ignores Indigenous, Inuit, and Métis knowledges and experiences, and this is unacceptable. So I work to incorporate when I can that information as much as I can as an outsider. If anyone has any suggestions on how I can improve, I'm happy to hear that and do the best that I can to improve this course. So we are wrapping up Unit 1 today, which is We Are the Guardian of Earth's Spheres. We've talked about how Earth is a superorganism and how both the living and non-living parts of Earth keep it healthy and also harm it if they are not healthy. So we've looked at the Earth spheres of land or soil, air, and water, and how they're all connected to each other as well as to us, and how we have impacts on them, which then has impacts on other life forms. So today we are looking closely at how we sample and monitor the quality of soil, water, and air over time. So we've talked about what soil, water, and air are and what they're made up of. We've talked about how humans haven't had an impact on them, but now we're going to talk about the science in terms of how we measure those impacts so that we can hopefully learn and make change and figure out how to improve the way that we impact the Earth. So our learning goals are such that at the end of this lesson, you will be able to explain how soil, water, and air are sampled and tested for contaminants, and you will understand the human impacts that result in soil, water, and air pollution and the associated risks to the environment. You know you've met these success criteria, these learning goals because of the success criteria, which are that you can explain how erosion and lack of nutrients due to human use impact soil health. You can explain how water is sampled and tested for pollutants, specifically in drinking water, and you can explain how air is tested and what contaminants are to look for in a sample. Okay, so why sampling monitoring? Why is this important? So we have learned already that human activity has negative effects on soil, water, and air quality. To understand these effects, people use different sampling methods and tests to monitor soil, water, and air over time. So sampling is when you take a piece of, or you measure a piece of that information and make conclusions about the entire thing that you're monitoring. The information they collect helps us ensure farmland and forests are healthy and productive. It also helps us learn more about how polluted air and water affect human health and natural habitats. So let's look at soil. So soil core sampling is the most common way to measure soil quality. Farmers can then decide how much fertilizer and what kind is needed to be used. Foresters learn the pH and nutrient levels, and environmental scientists measure pollution. So soil we've talked about is made up of sand, silt, and clay. but they are not mixed equally. They exist in layers called horizons. Soil core sampling means we can get a lot of information without disturbing a lot of soil. We don't want to dig up a whole area, but with soil core sampling, we are able to go deeply to get a lot of information about the depth, opposed to scraping a lot of surface area off. So here is a diagram that shows the soil profiles. So it shows if you were to take a core, so it means that you're cutting down. It's like you're cutting down in here and taking a piece out is how core sampling works, so that you get information about all of these different layers. So we have the O horizon, which is the first layer, the top 2 inches of the soil, and it's fresh to partially decomposed organic matter, as well as branches and leaves, as well as like animals and insects. And it varies from brown to black. We've talked about this topsoil being yesterday. Or the day before, we talked about topsoil. Sorry, last class last week, we talked about topsoil and how it's humus and how that's where a lot of the rich nutrients are. Then we have a horizon, which is the second layer and still part of topsoil, and it's about 10 inches, goes to about 10 inches deep. And it's highly decomposed, mixed up organic matter, and it varies from brown to gray. And this is the root zone where plants like to grow. So it's really important for a healthy layer of topsoil so that plants' roots can go down there and gather nutrients and grow from that. Then we have B horizon, which is a third layer, which goes to about 30 inches deep. And this is it's called a subsoil, and it's mostly clay and bedrock. So the clay is due to leaching from the above layers, and it has some root activity, but not too much, because as we talked about, clay is not great for plant growth because there's not a lot of space between the particles for water and air and roots to actually exist. And bedrock is just solid rock, so that's not great for plant growth either. Then we have C horizon, which is the fourth layer, and it's 48 inches deep. And it is called the parent material, and this is mostly weathered bedrock. So this is where some nutrients come into the soil because it is broken up of minerals that are deeper. And then R or D horizon, it's both called, is the last layer, and this is bedrock. So this is unweathered rock. So this is just solid rock. Some places in a lot of parts of Ontario and Canada, we have the Canadian Shield, which is exposed bedrock, which is just really solid, hard rock, which there's no other soil on top of, which means that it's not great for growing things. But this is what that solid rock is below everything as well. It's just that some places in Ontario and in Canada, it's exposed. So here are some more diagrams of these different layers. As you can see, when it's in real life, and that it's a little bit harder to distinguish opposed to the diagrams, but you can kind of see the different layers and where there's growth, and the color changes a little bit, and where the roots are changes a little bit. You can see all of that in these diagrams a bit. And it's also not like super straight, right? So like some things go kind of wobbly, because life is not super straight in most situations. All right, so in your workbook, there's a table that shows you sort of how to distinguish the health of the soil. So the soil color tells you the poor soil is a lighter color and is a sign of erosion, and good soil is a darker color, meaning that there's more organic matter and nutrients within the soil. Then the soil life is a number of earthworms. So the more earthworms, the healthier the soil. It means that there's more holes and the topsoil gets aerated and moved around. Also, soil life, the smell. So if it has a sweet forest smell, then that's a sign of good soil. Whereas if it has a swampy smell, then that's a sign of poor soil. This is something I'm sure that you get if you are paying attention to this. You understand it, you get a little bit used to it more, opposed to if I go in, I don't know if I'd be able to tell the difference between swampy and sweet forest. I might not be able to measure that. Then testing the organic matter, the plant roots. So having noticeable roots and leftover plant matter shows good soil, whereas if there's no visible roots or leftover dead decomposing plant matter, this is a sign of a poor soil. Compacted soil, if it crumbles easily and feels spongy, then that means that it's easy for roots to grow through, and so that's a good soil. Whereas if it's really dense and really packed in, then it has a hard time for plants to grow. The water holding capacity, you want good soil stores moisture so that it can, and then that can spread to plants, whereas poor soil, if it's really dry, if the soil is unable to hold water, then plants can't grow in that soil. And then the pH level, which you'd have to actually test. You can't just look at it. So for most soils, the pH between 6.0 and 7.4 is best. If it's too acidic, so less than 5.2, or too alkaline or basic, greater than 7.9, this is not good soil. That means that the minerals have become toxic and are not there, are either too much or not enough, and that's not healthy for the plants. So sampled soil is mixed up and then sent to labs for analysis. So this isn't all going to happen right in the woods or in the field. You're not going to be able to know all these things. Some things you might be able to know. But then farmers, foresters, and environmental scientists use all of the results to make decisions about how to improve the health of the soil in the area. So this information helps them figure out what they need to introduce. Erosion and lower levels of organic matter are the primary reason for poor soil quality. So then adding organic matter like manure or compost or a plant, so that helps give back the nutrients to the soil, or planting cover crops like rye, soybeans, sweet clover are things that help erosion not happen. They help keep the soil in place opposed to being washed away by wind or water. All right, so now you can do the key questions on page 19, the check your understanding questions 1 through 3. All right, let's look at water now. So for water sampling, we again are using this to find contaminant levels. If too high, then that means that there's a danger for aquatic organisms and it's unsafe for drinking water. And they use a depth integrated sampling water system. So similar to a core soil sampling is that you're sticking a long pipe down, you can see in this diagram, a long pipe down into the water to get not just the top of the water, but the depth as well, in order to get more information to go all the way down. So we're going to watch a short video about how this actually works. For some reason, sometimes it doesn't work.
Chasing that A and want to save time on proofreading? Grammarly makes editing one click simpler.
Okay, skip the ad.
Once you're out on the lake, here's how to take a lake sample. Make sure you've dropped an anchor. If it is windy, you might need to drop an anchor at both ends of the boat. Record the sampling time on both the plastic and amber bottles. Remove the stopper and rinse 3 to 4 times on the opposite side of the boat from where you'll be collecting your sample. Lower the integrated sampler into the water until the top is about 6 inches above the surface. Put the top rubber stopper in and make sure it's secure. Raise the sampler slowly out of the water. Replace the bottom stopper before pulling the sampler completely out of the water to prevent water loss. Invert the tube to mix the water 3 or 4 times. Do this slowly so you can hear it slosh. which is ensuring proper mixing of the water. Place over the amber bottle with the lid placed upright on a clean surface. Pull the bottom stopper from the bottom up to avoid water sloshing over your hands, which could contaminate the sample. Pour the whole sample into the amber bottle. If you are using a 1-liter bottle, which is smaller, remember that you will have significant overflow, so you might want to take the sample over a bucket. Shake the water to rinse and discard. This first step of rinsing the amber bottle is important so you can collect a good sample. You only need to rinse the amber bottle. The plastic phosphorus bottle is a single-use bottle that we recycle at the lab. To prepare the phosphorus sample, you will collect a second sample. Mix the water. Fill the amber bottle. Shake. Pour the water from the amber glass bottle into the smaller plastic bottle. Fill to the bottom of the bottle's neck. Pour the sulfuric acid that is contained in the small vial into the plastic bottle to preserve the phosphorus sample until analysis back at the lab. Cap the sample bottle and mix by inverting the bottle 4 or 5 times. Put the empty sulfuric acid vial back into its plastic bag and place back in the cooler for disposal at the lab. It's highly recommended to rinse your hands after handling the acid. Dump out any remaining water in the amber glass bottle. Collect your third and final sample to be used for the chlorophyll analysis. Remember to have your sampler stop about 6 inches above the surface and then cap it underwater. Mix well so you can hear it slosh. Empty into the amber glass bottle. Tighten the cap and place it in the cooler. And you're done. Now it's ready for transport to the lab.
All right, so that shows us how water samples are taken so that you reach down and are able to get a depth water that then they shake in order to mix everything up. Of course, there's some more details in terms of like chemicals and how it actually is testing, but we get sort of an idea of how that works. So then the types of testing with water samples. The Ontario Ministry of the Environment regulates these tests. And so there's a microbiological testing, which tests for microorganisms like total coliforms bacteria or E. coli bacteria. Not all coliforms are harmful, but some are dangerous, and a healthy water supply does not contain any E. coli. Then there's chemical testing, which tests drinking water for various chemicals, specifically nitrates and lead. There's radiological testing, which tests for uranium. Lower levels are normal, but high levels are concerning. And then there's other test methods that drinking water is tested for color, odor, taste, and turbidity, which is like how much sediment is in there. So water that is turbid is when there's suspended matter in it. So how much dirt and particles are in the water. The higher the turbidity is cloudier water. All right, so this is a image and from water tap, which is it's generally an advisory. It shows you the water boil advisories and other advisories in Canada. Now, when I was trying to go into it earlier, it was not working. So let's see if it works. Is the website might be down today, of course. So this is showing that in Canada, there are still significant number of water advisories across the country. They are going to be less, they are decreasing, and hopefully we're addressing it. But really, it's concerning that there's this many water advisories in Canada. Unfortunately, I can't get closer. If you go to if the website's working, you can go in closer and you can see actually where each of these are. So yeah, it's not working. Sorry. I'll link it in the show notes of the YouTube video, and potentially if it is working at a later time, you can go in and you can check it out. It's pretty interesting. But you can see in Ontario, there are 62 water advisories, either don't drink at all or water boil advisories. But if you were to click here in the website and go in actually into Ontario, then it shows you where the actual communities, where the sites are. And some of them are like campsites and public, like provincial parks and things like that. But most of them are First Nation communities, which is just really concerning in terms of the racism and injustice that happens in Canada and in Ontario. The fact that there are water advisories, doesn't matter if it's in northern remote locations, some of them are there, but also some of them are in southern Ontario where a non-Indigenous community next door will have perfectly clean water, and then the Indigenous community will not have clean treated water. And so that is a systemic issue that needs to be addressed. So the government of Canada and First Nations are working together in order to improve the water infrastructure. So this is something that is happening and has been happening. So making sure that infrastructure is updated and working properly and properly staffed, making sure that both long-term drinking advisories that have been on for decades are ended, and also preventing short-term new advisories from becoming long-term advisories. So it is something that is happening. It's constantly changing. So it's not something that I think that we can still do better, but hopefully things are already improving in communities. So since 2015, $5.2 billion were invested into First Nation communities. So 131 long-term drinking water advisories have been lifted, and 34 remain in 29 communities. This information is a little bit old, so I'm not sure if that's accurate as of today. There are 611 projects with upgrades funded and water treatment plants being built in communities. And they say 212 short-term drinking and water advisories have been prevented from becoming long-term. So there is paying attention. This is presented from a government site, so it's going to be biased in terms of saying that the government is doing great things. And I don't know if this is actually true on the front line of all of these communities, but hopefully things are improving. Okay, so those water sampling would be methods about how to check and how this is monitored in these First Nation communities. So that is water. Now you can do the key questions on page 22, check your understanding questions 1 through 3. And then finally, let's look at air. So stack sampling is one method about measuring air pollution and the things that are going into the air. And this is done directly at industries sites. So here are some images of, this is the Dryden paper mill. And this is another paper mill or another factory in Ontario. And you can see these big clouds of smoke of chemicals being put into the air. And so these stacks, these tall pipes that go into the air are smokestacks. And this is where sampling happens. So it happens directly at the stacks to see what is being put into the air. So it's not, sampling can also happen at the air in general to check air quality, but at these industries where they are putting chemicals into the air, they need to test directly at the source. So before it is exposed to the air, what it is that they are putting into the air. So most pollutants in the air come from industry plants fueled by fossil fuels. So that's what's going on here. This includes pulp and paper mills and metal smelters, oil and gas processors. They pump chemicals, gases like sulfur, mercury, and carbon into the air through these smokestacks. These are called emissions. So companies are mandated to regularly sample and monitor their emissions. Stack sampling is how they do this. So how this happens is that this red and black cut through is showing it. This is the inside of a stack. So we've sliced through a stack to see what's going on inside. And then they have these little jets and pipes that are stuck in, and then they open up and they suck in the air or the smoke, the chemicals, the emissions that are being pumped up through the stack. They get trapped in here and pulled out, and then go through this, pumps them out. And then there are various different ways of testing that gets tested right there on site. We do not need to go into how that works. That is beyond our scope, but understanding that we take the air sample directly out of the smokestack and then test it right away is what we need to understand how it works. So one of the things that they're measuring is fine particulate matter. And this is the main ingredients of smog along with ozone. So it's a mix of solid particles and liquid droplets, including aerosols, smoke, and dust. And it's created through chemical reactions and burning of fuel. They're known as PM 2.5 because the particles measure 2.5 micrometers or less. So an NM, a micrometer, is 1/1,000,000th of a meter strand of human hair. Oh, sorry, it's a 1/1,000,000th of a meter. A strand of human hair is about 100 micrometers wide. So this just gives you sort of a reference point of these particles are very, very small in relation to lots of things that we interact with, but these are still, so it's very fine particle matter, but inhaling them, breathing them in still has an impact on our bodies. We are still able to breathe them in, and then that it's not good for our health or other animals' health. So PM 2.5 can be inhaled and cause serious health problems. So this is why we're concerned about it. All right, so here we're going to watch another video about understanding air quality.
The air we breathe is the most important component for our livelihood, just like the food we eat and water we drink, but it is often taken for granted by us. Thus, there is a use of Air Quality Index, AQI, which is used to measure the level of air quality and how polluted the air is. AQI is generally measured by 6 levels of air pollution. The lower the level, the better. As soon as the AQI increases, the air becomes super polluted, having major bad health effects on our health. The levels range from being perfect, which ranges from 0 to 50, followed by moderate, from 51 to 100, from 101 to 150, asking sensitive people to look out, from 150 to 200, showing it unhealthy, 201 to 300 as very unhealthy, and finally, the most polluted, 301 and above, proclaiming it's hazardous. The more the level of AQI, the worse it is for the health of people. Research suggests that Delhi has one of the highest levels of AQI measured in any city in the world and is over 15 times higher than the AQI level suggested by World Health Organization, WHO. It's high time for people to know the importance and value of the air quality and the air we are breathing for a more clean and livable environment.
All right, so that just gives you a quick rundown of how the air quality index measures. So that's how we monitor the air quality. So the workbook is different, and I'm not quite sure. I wasn't able to figure out if it has changed recently or what, but all of the information that I found that is available now shows these numerical values and this monitoring, this index scale. So just be aware of that the workbook seems to be a bit outdated. So we're aiming for good, which is between 0 and 50 on the scale, and the air quality is considered satisfactory and air pollution poses little or no risk. Then moderate, which is measured as 51 to 100, and the air quality is acceptable. However, some pollutants maybe make moderate health concerns for a small number of people who are sensitive to air pollution. So under 100 means that we're probably okay. Then between 101 and 150, this is unhealthy for sensitive groups. So more people are experiencing health effects. generally, most of the public are not affected, but still it's concerning. So people with asthma or other breathing issues, people with potentially with long COVID or COVID are going to be affected more intensely. Then once you get to 151 to 200, then it's starting to get really unhealthy. So then more people are experiencing health effects, having a hard time to breathe. At 201 to 300, everyone is experiencing seriously health effects, so really hard to breathe and having other respiratory issues. And then greater than 300 is an emergency situation and everyone is going to be affected. So here is another website that shows the air quality index in Canada, as well as the US, but Canada is where we're focused. And you can see where that's measured. Green, these green dots show how that mostly we're good in Canada. It sort of follows the general population. I'm not exactly sure how they decide where these dots go, as we live up here and there's no dots, but anyway. It also shows air currents, which I'll click on the actual thing, we'll actually go to it, but which move to show how the air is moving, which I just find is pretty and satisfying. And it shows the fires, if there's fires anywhere. So right now, I took this picture today. So right now there are fires in southern BC / North Washington. I'm not sure exactly where this is. And then also in Alaska, there's another fire. So sometimes there's lots of fires and they show up. And so this is like changing information so that you can actually get current information. Hopefully it's going to work for me. I will share this in the link as well. So you can see again how it's moving. The air currents are moving to show how the air is moving in the world, which I just think is super cool. And then you can see across the world where there's health concerns. So these are the major cities in the world that have the most concerning levels. And so right now it's up to 162, which is in Pakistan. And so then it continued to see, you can see where the biggest concerns are and where there's not as much concern. Interestingly enough, we can also see where there's fires around the world, which is also interesting. It continues to show in terms of the how colonization and the global south has been resources have been extracted and as a response to or as a result of colonization and oppression, that North America and Europe and Australia are focused mainly in green, so have good health, good air quality, yet many places in South America, in Africa, in Asia, places that have been affected by colonizations, have been colonized, have been oppressed, have had their resources extracted, have poorer air quality and not as many are having more struggles. Just something to think about in terms of air injustices. So if we go back outside of the map, we can then also look specifically in Canada, where you can see where there's good air quality and where there is more concerning air quality. So BC, I wonder if this is around where the fires are right now, where there's the lower air, more concerning air quality. And then you can see where the cleanest city, so last year the cleanest city was Labrador City in Newfoundland and Labrador, and the most polluted was Savona in BC, and the average is 1.7 times what the guideline is from the World Health Organization. So we're good, but we're still, if we're not careful, we can continue to be less. So anyway, so I find that just really interesting, and it's something that you can go check out if you would like to look at that in more detail. I'll link it in our show notes. So poor air quality symptoms. So if you are experiencing poor air quality, it doesn't affect everyone the same way. But generally people report one or more of these symptoms. So dryness and irritation of the eyes, nose, throat, and skin, headaches, fatigue, shortness of breath, hypersensitivity and allergies, sinus congestion, coughing and sneezing, dizziness, nausea. So they can be symptoms of other things as well, but it's good to check if you are experiencing this a lot, any of these things a lot, and you can't figure out what could be going wrong, to check out your air quality. It could be something to do with your air quality of where you're working or living. So what are actions that we can take to reduce air pollution? So we can conserve energy, right? If we're using less fossil fuels, then we are putting less into the atmosphere. We can look for Energy Star labels when we are buying home and office equipment. So these are going to be things that are more energy efficient and using less fossil fuels. We can carpool, use public transportation, bike or walk whenever possible. We can follow gasoline refueling instructions for efficient vapor recovery. Being careful not to spill fuel and always tightening your gas cap securely. We consider purchasing portable gasoline containers labeled spill proof when available. We can keep cars, boats, and other engines properly tuned so that they are burned more efficiently and have less emissions. We can ensure your tires are properly inflated. Again, this makes less emissions. We can use environmentally safe paints and cleaning products whenever possible. We can mulch and compost leaves and yard waste. We can consider using gas logs instead of wood. And we can pressure our governments and businesses to take actions. These are a lot of things we can do at a personal level, which is great, but it's also important to recognize that governments and corporations and businesses are the ones who have a lot of emissions and are the ones who have a greater impact on overall. And so we can pressure them to be making environmentally friendly choices. All right, so that is our lesson 3, here are highlights of sampling and monitoring quality over time. So soil, we talked about the core soiling testing and how we looked at soil profiles to see how the health of soils is measured. We talked about water in terms of how water sampling and testing is done, and water boil advisories. Sorry, I have hiccups. And we talked about air and how stack sampling is how we measure air quality, and how the air quality index shows us when we need to be concerned and what might be impacting our communities. So the success criteria, hopefully you can explain how erosion and lack of nutrients due to human use impacts soil health. You can explain how water is sampled and tested for pollutants, specifically in drinking water. And you can explain how air is tested and what contaminants to look for in a sample. At this point now, you can do the review questions on page 27, 1 through 11. These are your key questions. And as always, if you have any questions or concerns, please reach out and contact me. My number at the office is 807-737-1488, extension 2209, or toll free 1-800-667-3703. You can email me at bronwyn.slate, and that's spelled BRONWYN.SLATE@nnec.on.ca. You can Facebook me at bslate Wahsa and watch replays of this, as well as the supplementary videos if you'd like to watch them again and find them from the original sources from bslate Wahsa. I hope you have a lovely day, and thank you so much for joining me. Which